Okay, so we're going to be finding the limits as x approaches infinity, or the limit as x approaches negative infinity. I want to talk to you a little bit about that. If you have a problem, let's just talk about a graph first. If you have a graph like this, and I want to find the limit as x approaches infinity of that graph, the answer is going to be 0. And the reason is because as I get closer and closer to the x-axis, that's where the graph is going. You look at, like, to the right of the graph or to the left of the graph. If you talk about the limit as x approaches negative infinity, it's still 0. Well, if I have a graph that looks sort of like this, maybe it has some other things going on. Maybe it looks sort of like this, and I want the limit as x approaches infinity, or the limit as x approaches negative infinity. Well, on this graph, remember infinity and negative infinity, I'm thinking about the right side and the left side. I don't really care about that middle part. I just really want to know where the graph is getting close to, or what the y value is getting close to on those parts. Well, this is 1 and 2, so as I approach infinity, this one is going towards 2. This is negative 1 and then negative 2, so as I approach negative infinity, this one's going towards negative 2. Notice that on all of these problems, the horizontal asymptote was really important. So when we're finding the limit as x approaches infinity or negative infinity, most of the time we're going to be looking for the horizontal asymptote. Because if we can find the horizontal asymptote, that tells you what's going on the ends of the graph. So you might remember from pre-calculus, there's 3 rules about horizontal asymptotes. I'm going to abbreviate there. First of all, if you have a function where the top and the bottom have the same degree, then the horizontal asymptote is the coefficients divided. So if I have f of x equals x plus 2 over 3 minus 2x, and I want to find the horizontal asymptote, I realize that the top and the bottom have the same degree because the highest power on top and bottom are the same. So the horizontal asymptote, I just take the coefficients of those things, so a 1 and a negative 2, that means the horizontal asymptote is y equals negative a half. In turn, if I wanted to find the limit as x approaches infinity or as x approaches negative infinity of this function, the answer is negative a half. The horizontal asymptote is the place where the graph is getting close to as you approach infinity or negative infinity. Second rule. If the top has a less degree than the bottom, then the horizontal asymptote is y equals 0, which means on the ends that the graph will be approaching 0. If I have something like this, the limit as x approaches infinity or negative infinity of something where f of x is x over x cubed minus 2. Notice the top is a less degree than the bottom because the top has a power of 1 and the bottom has a power of 3. And so that means that the horizontal asymptote is y equals 0, which means the limit is also 0. Because when I'm thinking about horizontal asymptote, I'm thinking about y values, and I'm thinking about what happens on the ends, which is the limit as you approach infinity or negative infinity. The third case is if the bottom has a less degree than the top. That means that there is a slant asymptote. And I just want to remind you real quick what a slant asymptote looks like. If that's, the purple is the slant asymptote, the graph gets close to that asymptote on the ends. Or maybe the graph does something like that. And again, notice on the ends, it's getting close to the slant asymptote. And what that means is that the limit as x approaches infinity or negative infinity on those is either infinity or negative infinity. And to figure it out, you kind of just plug it in. And I'll show you that. Okay, so let's say you had the limit as x approaches infinity of f of x, and we had x squared minus 3 over x plus 1. So I know that there's a slant asymptote of that graph. So as I approach infinity, I know that my answer is either infinity or negative infinity. The graph's either going up or going down. So just think about plugging in like a big number in for those x's and see if you get a positive or negative. So if I plug in big numbers there, I'm going to get a positive because the top would be positive, the bottom would be positive. So that means that the limit would be positive infinity. So that's sort of what I mean about plugging in numbers, just kind of seeing whether you would get a positive or negative, and then the answer is either infinity or negative infinity. So let's do a few examples. So here we have the limit as x approaches infinity of 2x minus 3 over 4x plus 5. Again, anytime you see infinity or negative infinity is what you're approaching. You're looking for the horizontal asymptote. My rule says I look at the highest power on top and bottom. They're both the same. So I divide the coefficients and I get a half. And so that's the limit. On this one I'm approaching negative infinity. Again, I look at the powers. They're the same on top and bottom. So that means I divide the coefficients, the numbers in front of the x's. I get negative 3/2. I don't have to worry about whether it approaches infinity or negative infinity, because on these particular problems, they're doing the same thing on the ends. Both of them are approaching the horizontal asymptote. Number 3, I'm approaching infinity, looking at the powers. The top is kind of like an x to the 0, and the bottom is like an x to the 1. So the top has a less degree than the bottom. That means the limit as I approach infinity is 0, because that's the horizontal asymptote. Alright, I'm approaching negative infinity. Still look at those powers. We have, that's really a 1 and a 2 on the bottom. Top is still less than the bottom as far as the degree is concerned. So this limit is 0, because that's the horizontal asymptote. Alright, this one, the limit as x approaches infinity. Looking at those powers, the bottom has a less power than the top. Top is bigger. That means there's a slant asymptote. That means my answer is either infinity or negative infinity. And basically I'm just going to plug in a big number and try to figure out what would be going on. So 4 times a really big number to the 4th, I know that would be infinity. 6x to the 3rd, well, that would still be a big number, and it'd be positive. And so subtracting a 19 from a big positive number would still be positive. So that means infinity will be my answer and not negative infinity. Okay, another one very similar. It says negative infinity. Looking at those powers, the top is bigger. So I know I'm looking for a slant asymptote, which I don't have to find, but I know that that means my limit's either infinity or negative infinity. So again, think about plugging in some big numbers here. I'm plugging in a negative big number there. Well, that would be negative when I cube it. But then I multiply by a -5, so it ends up being positive on top. On the bottom, a negative big number squared is going to be positive, and then subtract 7 still be positive. So we have positive infinity. Alright, the square root ones are a little bit different. They're the only ones that there's a possibility of 2 asymptotes. So on the ones we've done so far, there's only one asymptote, and on the ends, the graph is approaching those asymptotes. But when you have a square root, whether it's on top or bottom, there's actually 2 asymptotes, and it has to do with the graph. So what you do is the same process as before, but you figure it out with infinity, and then if the problem said negative infinity, you would change the sign, and this only occurs when you have a square root. So we're going to look at the powers here. The power on top is a 1. Now the power on the bottom, I'm not going to worry about that 4 right now, but just to think about what the power would be, that's the square root of x squared. Well, the square root and squared means I'm talking about an x, so even though it looks like that, it's sort of like an x, so the top and the bottom have the same power. And then to find the limit, I just divide the coefficients, which is just 1, and then square root of 1. If there were a 2 there, then it would be a square root of 2 on the bottom. But since it's just 1 divided by square root of 1, we would get 1 for the limit. Now if the problem would have said the limit as you approach negative infinity, like this one right here, then I do change the sign to a -1. So whatever I get when I do infinity, if it says negative infinity, I change that sign. So here's another square root one. This one's on top. It really doesn't matter where it is. Still there would be 2 asymptotes. I realize that the top, that would be the square root of x squared. So that's still x. And that's to the first. So we still have the same degree. Take the coefficients, square root of 3 and 1. So that's square root of 3 over 1 or square root of 3. That would be the limit as you approach infinity. Because that says negative infinity, we go back in and we change the sign. So negative square root of 3 would be the limit. Alright, if you have a problem where you're adding things together, you could get a common denominator if you want to, or you could just find the limit of that one and then the limit of that one and then add. I actually think that's easier. I'm approaching negative infinity, but because I don't see a square root, I don't need to change any signs. Look at the coefficients. We have a 1 and a 1. And the degrees are the same on top and bottom on this, but the limit of that one would be 1. Over here, 2 over x, the bottom is a bigger degree than the top, so the limit's going to be 0. So 1 would be the limit on that problem. And you can just add those two things together. Here's a few problems to try. And don't forget that along with the video and these problems that your green sheet is also due. And I'll be taking that up.